because I had another shirt in my hand and I thought, oh, I'm going to wear khakis. No really good reason. It was a decision, but not really a deeply meaningful decision. It was just a decision. Have I ever put one before?
Never.
Ever? And I'm in your
Never.
seventh grade year of your freshman year?
Never.
No. I remember. That's reality. How about homework questions?
39. 45.
42. 43.
Wait, 39. Or did you not do it?
My recording.
Yeah. I think I skipped that one.
We know how to do these first ones.
Yes.
We're solving these equations, pretty much, you factor it, and you find the values of x or y or m or p or whatever it is, and see, I have to work away because I'll keep doing that. You have to find the values that make it true. So you get everything to one side so it equals 0, factor it, so all the factors equal to 0, and that's how you solve it. How I find the zeros. It's the same thing, right? Everything's all on one side already. All we have to do is factor it, set the factors equal to 0 and solve it. Okay. You find the possible rational zeros. It is on the quiz. You know how to find the possible rational zeros. That's good. You guys are awesome. I appreciate your honesty. I think something we should go over. What is your issue? Okay, for 23, we're trying to find all the possible rational zeros. They did it mostly right. Right? You take this last number of the polynomial, because the numbers have to multiply to get that number. Like if you factor it, you got a bunch of factors, all of these numbers have to multiply to get that last number. Right? Or if it's 2 factors or whatever it is, if you FOIL this out, all the first things will multiply to get the first term in the polynomial, and all the last numbers will multiply to get the last number in the polynomial. That's the way it works out. So, you take the last number and find all the factors of the last number. Okay, so the last number, 1 and 45 are factors of 45. Not 2, because it's not even 3 is. And if you don't know what 3 times whatever is 45, you can just divide it on your calculator and get 15. So 3 times 15 is 45. Okay. I do not have the patience. Not 3. 4 is because it's not even what 5 is. 5 times 5 is 45. Okay, so those are all the factors of 45. And all the factors of the first number, which is 1, is easy because it's just 1. And then all the possible rational zeros are all the fractions you can make with these numbers on the top and this number on the bottom. So plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 9, plus or minus 15, and plus or minus 45. So you can see what they did wrong. They did it mostly right, they just forgot half of the possible answers. It's positive or negative version of all these numbers. So I would take off half, we do this. Okay, we have to remember the plus or minus sign. These, same deal. Which one's even? 8 is that last number of the polynomial, the factors of 8 are 1 and 8, 2 and 4. The first number of the polynomial is 3, the factors of 3 is 3 and 1. And all the fractions you can make out of these, 1 over 1, 1 over 3, 1 over 1 is 1, 1 over 3, 2 over 1, 2 over 3. 4 over 1, 4 over 3. And 8 over 1, 8 over 3. I was thinking about it. Any questions? Now we're good? You know how to do these? Find the, yes.
Do you have to put them in like numerical order? Or no, there's not one? Okay.
Just list all possible rational zeros. 25, 26, all the way through 32. Find all the real solutions. So we're trying to solve this equation. Our answer will be x equals x equals x equals. You can get all the answers by just graphing them. Right? If you graph this one, you would get 3 answers. And the 3 numbers are actually multiplied to negative 15. No, they would probably multiply. Yeah, they would multiply to negative 15. Let's check it. Because the factors will be x minus first 0, x minus second 0, x minus third 0. I just said that, it just came out of my mouth. I'm pretty sure it's reality. Just like it did a new connection that I made just today. X to the third plus x squared. Minus 18x. So the zeros are negative 5, positive 1, and positive 3. Those multiply to negative 15. Because the factors are x plus 5, x minus 1, x minus 3. And if you multiply the last terms and all the factors, they multiply to positive 15. That's a fun connection. Okay, anyway, that's what you do with 25 through 32. You graph it and you get some of the zeros. I'm going to do this one. So you start it by graphing. You guys probably should have calculators with you. Unless you're leaving it more than that.
Yeah.
You can do it.
Okay. I'm not wanting the next minute.
Sit back down. He said I could leave. Bye. Do you need this?
Okay. So then what you need to do is synthetic division with these coefficients and one of these zeros. Anyway, the answer to this will be negative 5, x equals 1, x equals 3. Those are the answers. We have the answers worth half the credit. The other half is justifying that those are the answers. So we put negative 5 in the box, or any of the other ones. With coefficients of 1, 1, negative 17, and positive 15. Look at remainder of 0. If you don't, then you made a mistake. We know the actual numbers. X is negative 5, not necessarily the factors. If we had to write this in factor form, our factors would be x plus 5, x minus 1, and x minus 3. And the number you put in the box is the opposite sign of these. But if you know the zeros, then that's the number you put in the box. X equals negative 5, negative 5. Drop down 1, negative 5 is negative 5, add these together, negative 4, times negative 5 is 20, add those together, negative 3, times negative 5 is negative 15, plus the remainder is 0. And this gives you the coefficient for a second degree polynomial. Yes?
How do you find the zeros in the calculator? Do you use the y equals?
So I looked at it and knew what the zeros were. Because the zeros are where it crosses the x-axis. And it crosses the x-axis at 1, 2, 3, negative 5.
Well, how do you graph it first?
1. How do I graph it?
Yeah, you use the y equals.
Yep. Put it in y equals. And graph it. That's x squared. Minus 17x. Plus 15. Oh, zoom 6. 6. This, when you, is a second degree polynomial, right? This is x squared minus 4x plus 3. And then plus factor into x minus 1 and x minus 3. So we showed that negative 5 is, by using synthetic division, to give you a remainder of 0. We show that the other two are by factoring the remaining polynomial and getting those two as the factors, which means those two are the solutions. Okay? Any questions? Yes.
The first one, the afternoon there, it's the same as the final answer, just switch the signs. Did that happen for all of them?
Well, I knew these factors because I looked at the graph of them. And I knew the zeros, and then once I had the zeros, I struck down the factors. And then I just showed that those are the factors. Okay? These 33 through 38, I know the real zeros. I know the real solutions. So these are similar. Like most of these will turn out pretty much the same. However, it could be that when you use the synthetic division and get something like this, it's not factorable. And if that's the case, then you have to use the quadratic formula. Okay? Life number 38. Is one of the ones that you wanted to see. Yes.
It's 39 in that division. And 39 is one that I think
39 is one like that too. 39 is nice because it's graphed for you just to look at it. Right? We're using the graph to shorten the list of possible rational zeros. Because the list of possible rational zeros are the factors of 16 over the factors of 4. take this polynomial, one in the box, coefficients are 4, 0, negative 20, 16. Drop down to 4. So these are the coefficients of the second degree polynomial, 4x squared plus 4x minus 16. That's not a factor. So we only know one answer. It's 1, and we proved that it was an answer. And we need to find 2 other ones, and the way we're going to do that is use the quadratic formula. And we can find the other ones, you know, if we can solve this equation. Luckily, we can factor 4 out. Divide that 4 away. So for the numbers we use in the quadratic formula are 1, 1, and -4. Okay? So b squared minus 4ac is 1. A is 1. C is negative 4. 1 plus 16, 17. Okay, so x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Those are the other 2 answers. Negative 1 plus the square root of 17 divided by 2. And negative 1 minus the square root of 17 divided by 2. Hopefully I'm not in the way. Everybody good? Anything else?
45.
Not terrible, yes. So we're writing the polynomial with the lowest degree, named f, leading coefficient of 1, with these zeros. So x plus 6 is one of the factors. X minus 0 is a factor, which is just x. X minus 3 minus the square root of 5 is a 0. What's the other factor that's not listed?
X minus 3 plus 35.
3 plus square root of 5. So the other factor is x minus 3 plus the square root of 5. So these are all the factors. First one's x plus 6, x minus 3 plus the square root of 5, x minus 3 minus the square root of 5. Okay? Now, I used to really, oh no, did it get dirty?
No. Oh, right over
Is it? What is that?
there.
Is it dried out? Oh, it's a little bit sad. Did you need to white out something?
It's okay.
I have white out. It's the best white out.
Sure.
It's the greatest in So I tried this once, like to show my class how great it was, and it turned out to be the absolute greatest thing ever. I'm gonna multiply those two trinomials to give a box. And I know that sounds like it's an elementary thing, but it really worked out well. X minus 3 plus the square root of 5. X minus 3 minus the square root of 5. So when we multiply this is, let me put an X in. This is x squared, it's minus 3x. It's plus x squared 5. This is minus 3x. That's plus 9. This is minus 3 squared 5. This is minus x squared 5. That is minus 3 plus 3 squared 5. Calibration's often I lost my calibration by the mind. Just a second. Minus 3 square root of 5. That's not so low. And then the square root of 5 times the square root of 5 is what number? How about this is fixed? Square root of 5 times the square root of 5 is 5, so this is just minus 5. Our factors are x plus 6. And this one's x squared, right? Minus 6x. These two cancel. And these two cancel. Plus 4. Now all I have to do is multiply x plus 6 times this. Easiest thing. I'm going to do it over here. X and 6. Okay, so I got x times x to the third minus 32 x plus 24. And it is x to the fourth. That. I can't give you one like that in the test. I don't think. But I'm pretty sure I gave you one with like negative 5 as a 0. So then the negative square root of 5 is a 0. Then the factor would be x plus the square root of 5. And if negative square root of 5 is a 0, then positive square root of 5 is a 0. Oh, here we go.
That's easy.
So if these are your zeros, it's not this. Those are your zeros. And your factors are x plus 6, x, and x plus the square root of 5. And if the negative square root of 5 is a factor, then positive square root of 5 is also a factor. And x minus the square root of 5. Now these are conjugates. And the beautiful thing about conjugates, when you multiply them, the first thing squared minus the second thing squared. If you multiply these together, you get x squared minus 5. And you can multiply that by x plus 6 pretty easily. And you multiply by another x pretty easily. So it would be like that in a test. Okay? Any questions? So how many solutions does this polynomial have? Can you give me a 3? Like a European 3?
That's almost.
Are you? Is that what you do? You say 3 like that? Like you're an official in a basketball game? I'm like, I'm this all day. You do this?
No.
Like that? That is, like you can't order 2 beers because you'll get 3.
This is
Because
mine.
2 is this and that's 3 in Europe. And I said beers because I don't know why. Because I'm recording it, that's why. 2, 3, exactly. So that's European 3.
Wait, so what's one then? Is this one? This?
I don't know. I think you'd be fine saying you don't. Because there's only one. If you order 1, I'm going to get 2. One soda pop. Let's say. This says 3 because the degree is 3. There might be some repeated solutions. Multiplicity 2. Repeated solutions, we call it that. Like if you have a factor of x minus 2 squared, then positive 2 is the 0 and it counts as 2 solutions, right? It might have imaginary solutions, but there are 3. How many solutions does this have? 4. You understand how easy these questions are. You will be on a quiz, not tomorrow, not Friday, I mean, but the week after, right? They'll be on the quiz. They'll be this question, how many solutions does it have? And just some weird polynomial, you look at the degree of it, and that's your answer. Got it?
Yep.
So now, this is what we've been working up to, a problem like this. 5th degree polynomial, it asks you to find all 5 zeros. There might be repeated solutions, but that will just count as 2, unless it's a binomial to the 3rd power, and it'll count as 3. So, we graph this. Hopefully you find 3 normal, crosses the x-axis at normal numbers, and the other 2 you'll have to use the quadratic formula to find. Now in this section it says, no, the question of the day is how can you determine whether a polynomial has imaginary solutions? Like right there, see that's the essential question. So you know it's a possibility that it has imaginary solutions. Here it is. You guys haven't graphed yet?
No.
Come on, get on.
Oh.
I had this in my calculator earlier. I should just use a different calculator. Now I covered it up, so it's bad.
No, I only got 2 solutions.
Plus 8? No.
No, one solution.
So I have -1 as a solution, but it's a double, so that means I can use synthetic division with -1 twice. And 2 is a solution. So it has 2 imaginary solutions.
Why not 3?
Imaginary solutions come in pairs.
But then what is the other solution?
There's 2 at -1, and there's 1 at +2.
Why is there 2 out of
So if I'm listing I'll have probably 2 imaginary solutions. So I'm going to use synthetic division with -1, with 1, 0, 1, -2, -12, -8. My remainder will be 0. 1, 2, 4, 4, -8, +8, 0. Okay? Now look at, I'm not changing anything. I'm just doing it again using these numbers, these new numbers. -1 a second time. My line only has to go to the 8. I'm definitely getting a 0 as my negative 1, -1, -2, positive 2, 4, -4, -8, positive 8, -0. So this was a 5-degree polynomial. What I got after I divided by a 1-degree polynomial was a 4, and then I divided by a 1-degree polynomial, and now we have a 3rd-degree polynomial. I'm going to do it again with 2. And I'll get something that hopefully I can factor, and if I can't factor, I can use a quadratic formula. It might be imaginary. 1 times 2 is 2, 0, that's awesome. 0 times 2 is 0, and those together make 4, 4 times 2 is 8, and together make 0. So this, when I apply x's to it, is a 2nd-degree polynomial. This is 1x squared plus 0x plus 4. That is this equation, x squared plus 4. So if I had to write this in factored form, which is a thing, my factors would be x plus 1 squared. That takes care of both of these -1 zeros. X minus 2 and x squared plus 4. But I still have to find those last 2 zeros. So I can actually set equal to 0 and solve for x. If you subtract 4, you get x squared is -4. Square root both sides with a plus or minus, you get x is plus or minus square root of -4. What is the square root of -4? 2i. 2i. So x is plus or minus 2i. And that's all fine. -1 twice, you don't have to list it twice, I just did to be dramatic. Positive 2, positive 2i, -2i. Yes?
How do you know if it's 2 negative 1s or just 1?
How do I what?
No, when you have 2 negative 1s, just like 1,
It's because of the way it touched the curve touched the x-axis. Right, when it touches the x-axis and bounces off, that means the multiplicity of that factor is 2. That's why I have the x plus 1 squared. And it counts as 2 solutions. When it goes through the x-axis, that means the multiplicity of that factor is 1. That's why I have x minus 2 in the first spot. These are the 2 imaginary. Okay? Good work. Thank you for working with Gia.
Oh, yeah.
Have you done that much?